Okay, our new unit, we're going to focus on quadratic functions, quadratic equations. We're going to be graphing quadratic functions, finding intercepts, domain, range, all that fun stuff. And we're also going to be solving quadratic equations. And we're going to start with the vertex form of a quadratic function. And so in order to do that, we're going to start by just identifying key features of quadratic functions and learning some key vocabulary. So today our focus is parabolas, quadratic functions, vertex form. And so here are some of the basics. Again, there should really be next to nothing that's new here. As we are exploring these quadratic functions, we want to make sure that we're dealing with a function that has this form ax squared plus bx plus c is equal to y or f of x or g of x, etc. This is rooted in a parent function, y equals x squared, as you can see graphed right here, or f of x equals x squared. The graph is called a parabola, and the parabola is symmetric. There is a vertical axis of symmetry, this vertical line right here that goes through the vertex. The vertex is that either lowest point or highest point on the graph, and that vertex is going to have a location, an x comma y, that we'll typically refer to as h comma k. And so the vertex form for a quadratic function, all right, this is the standard form, but this here is our is our vertex form. And this is where we have a times the quantity x minus h squared plus k. You'll notice that the way that this is drawn out that you can see the vertical stretch listed here, the horizontal translation, the vertical translation, not focused any at all on the horizontal stretch or compression, so that should help a lot. And we're going to be able to identify where that vertex is. We're going to be working between these forms over the course of this unit, but today our focus is vertex form. All right? And so, given this, this general form that f of x is equal to a times the quantity x minus h squared plus k, we're going to try to recall from our previous unit what these numbers are going to do to the transformation of our parent graph y equals x squared. So reminder, when we are subtracting h, whatever h is, that's how far to the right we're going to go. If h is a positive number and we're subtracting 3, then we're going to go 3 spaces to the right. If we're subtracting negative 3, then it's going to be the opposite direction, right? If it's x plus 3, then we'll go to the left. Plus k on the outside is going to move it up that many units. If we're adding a negative number here, that'll actually pull it down, right, up in the opposite direction. And then the a value is going to be our stretch or compress vertically, and it's also going to tell us if we're going to be flipping that parabola, opening upward or downward. And so we're already familiar with these ideas that if we have a positive multiplier, then we're opening it upward. If it's a negative multiplier, we're opening it downward. If it has an absolute value bigger than 1, it's going to be a stretch like the rubber band. Whereas if it has an absolute value between 0 and 1, it's going to be a squish or a compression, like the gummy bear analogy. All right, so we're only focused on vertical stretches or compression. We're focused on opening upward or downward, left or right, and then up or down. And so that's what we're going to be doing with our parabola. So let's describe these transformations. When we are talking through these, again, I will do some, but then I'll ask you to do some as well. I think it's healthy and helpful if you get to try and practice and then take your questions in class and then see how we do. I will do these items here. All right, so these items here, this is going to be moved to the right 2 spaces because it's inside of the parentheses. All right, it's inside of the parentheses. Here, this is outside. And so this is going to be a down 4 spaces. We're going to take our regular f of x equals x squared, and we're going to move it down 1, 2, 3, 4. It's the same picture, same shape, same size, just move down. Over here, there's 2 things happening. We have a plus 2 inside, so that's going to be a left 2. And then we have this multiplier. There's 2 things to pay attention to: the size of the number and the sign of the number, all right? The size of the number and the sign of the number. So the first thing I'm going to do is talk about the fact that this is going to be compressed by a factor of 1/2, and then it's going to be reflected upside down. Reflected over the x-axis is how we would write that. All right, sorry for my handwriting. Hopefully you're hearing what I'm saying. All right, so compressed by a factor of 1/2. So that means that the picture is going to be squished so it's only half as tall as it otherwise would be. Obviously the graph goes into infinity. We're just talking about if at x equals 2, the output is 4. Instead of it being 2, 4, now it's going to be 2, 2. All right, and so it's going to be half as tall as it was. Those y values, those outputs are multiplied by 1/2. And in this case, negative 1/2. Here again, two things. We're going to go to the right 5, and then we are going to flip it or reflect over the x-axis. It's going to open downward. The picture's going to look like that. All right, the picture's going to look like that. The picture's going to look like this. The picture's going to look like this. All right? And so that's all that we're talking about. I would like for you to do these. You do. Yay! You do all 3 of these. So take care of those. Pause the video because I'm going to move on while you do that. All right? Well, not while you do it. But I'm going to move on. All right. The features, the key features of a parabola. All right? So the key things we've already I've talked about it. I've alluded to these already. The first thing is the vertex. The vertex is the point where the graph changes directions. All right? Here it's increasing, and then now it's decreasing. Here it's decreasing, and now it's increasing. This is the minimum value or the maximum, the lowest point or the highest point. The maximum value would be the y value of the vertex. Y value of the vertex. Your vertex is your h comma k, your highest or lowest point. The axis of symmetry, this is a vertical line, x equals h. All right, whatever that h value is, that is the equation for our vertical line. Remember, vertical lines are x equals the number. And so if this is translated right or left, if it's x minus 2 squared, then 2 is what we're going to have here. X equals 2 for our axis of symmetry. Our domain is all real numbers. And so we can write that as negative infinity to positive infinity, or we can say negative infinity is less than x is less than positive infinity. The range is going to be from the minimum or maximum. So if it opens up, it's going to be from the k value, comma, infinity. If it opens downward, it's going to be negative infinity, comma, the k value. All right, and so we obviously have to pay attention. But the y value of the vertex is going to be our minimum or our maximum value. How high does it go? That's we're talking about the y value of the vertex, which we call k. All right. Over here, when we're talking about domain and range, we want to again use that proper notation, that interval notation. We can use set notation if that's what you want to. All right. So we have this key information. Now we're going to analyze some graphs. We're going to analyze some functions and what their graphs should look like. The reason why we're doing it this way instead of, why don't you just type it in your grapher? The thing that we're doing here is we are trying to predict what it looks like before we graph it. That way when we graph it, we can tell if we mess something up in the grapher. So we're going to locate or describe these things. So f of x is the opposite of x plus 4 squared minus 5. So I know by looking at this that we're going to go left 4. We're going to flip it over so it opens down, and then move it down 5. That would be the order of the steps that we would take. All right? We're not stretching or compressing because this is just -1. The absolute value of a is 1, and so it's neither bigger than 1 or less than 1. The vertex is going to be h, comma, k. The axis of symmetry is going to be x equals h. The minimum or maximum, this is going to be a maximum at k is equal to -5. A maximum at y equals -5. The domain is going to be still all real numbers. But the range, since it opens downward, is going to be from -infinity up to -5 and includes -5. It does touch the vertex. That's a point on the graph, so that's why we have a bracket there. So again, thinking through what this looks like, I could draw or sketch a graph of this without having to use the grapher if we understand the mechanics of the parabola. Now, obviously, we're maybe going to be a little confused on how far out and over and up and down and all that stuff. We're going to get better at that because we're just going by perfect squares, right? But we're going to get better at that as well, so we can kind of predict what our parabola will look like. I would love, love, love for you to try this. I will give you the answers in class, but you try that for your final extra U work point there. And so do that, please, so that we can see what this is going to look like. You get to try example 2B. Label that for me too in your notes. Label it for you in your notes so that you know what's what. All right, graphing parabolas. Okay, we're going to do this one. And actually, I'll do both of these. But basically, our parent form is going to be squares, right? 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. This is our parent form. This is what that will look like. And so we're going to take that parent form and then we are going to transform it, all right? We've got vertex form of this standard form. And so I'm going to say that we are going to move, again, left 1. We're going to stretch by 2, by a factor of 2. We're going to flip it over, so it opens downward, and then we're going to move it up 1. There's an order to those steps, and those are the things that we're going to do. So we're going to move to the left 1. We're going to stretch everything by a factor of 2, so we're going to double each of those as we flip it over. So I can kind of mark these out as far as what they'll look like along the way. That's the first iteration. We're going to stretch it by a factor of 2. So these 9s now become 18s. Well, I'm not going to be able to fit those on my picture. But these 4s, when I double them, they're going to give me 8s. And so I know what those are going to look like. These 1s are going to give me 2s. And so now our picture is more narrow, right? It's more narrow. It's going to look like this. I'm going to erase this in just a second. All right, it's a lot more narrow, right? This one is a little wider, this one's a little more narrow. We're going to flip it over. So now the 0 stays 0, but the positive 2 becomes negative 2, the positive 2 becomes negative 2, the positive 8 becomes negative 8, positive 8 becomes negative 8. And so we've now got this drawing. And then we're going to move everything up 1. All right? So I'm going to move this up 1, and we're going to have this point, this point, this point, so I can get rid of those. And then these all come up 1, I can get rid of those. And now I've got my new parabola. Now what you could do here, right now, with your grapher, or go to desmos.com, you can check what does y equals negative 2 times the quantity x plus 1 squared plus 1. Is it going to look like this blue graph? And the answer is yes. All right, letter B. I said I would do these for you. We're going to take our standard graph. We're going to move it to the right 3. We're going to squish or compress by a factor of 1/2. And then we're going to move down 5. So we're going to take this picture right here, which I'll draw in black again. 4, 9, that's our picture. When I say half, these outputs of 1 and 1 are going to be 0.5 and 0.5. These outputs of 4 and 4 are going to be 2 and 2. These outputs of 9 and 9 are going to be 4.5, 4.5. So it's squished by a factor of 2. At 4, it's going to be 16, so I know those are going to come down to 8. So I can predict that because we can think about what that table of values looks like. But we're going to move this to the right 3. We're going to squish it by a factor of 1/2, and then we're going to move it down 1, 2, 3, 4, 5. All right, so instead of going over 1 up 1, I'm going over 1 up 1/2. Instead of going over 2 up 4, I'm going to go over 2 up 2. Instead of going over 3 up 9, I'm going to go over 3 up 4.5. Instead of going over 4 up 16, I'm going to go over 4 up 8. And so this gives me a picture. It's a little wider of what that parabola is going to look like. Okay? And that is how we graph parabolas in vertex form. So what I would like for you to consider is kind of this summary of some key content, thinking about what our graphs are going to look like in Vertex form. This should be, hopefully, very accessible information, especially on this side of our transformations conversation last unit. See me with questions.